Hi there guys, in this video we're going to have a look at probably the toughest type of quadratic modeling question they can ask you. I made this one up, so you're never going to find this anywhere. It's all about Apple's watches. Okay, so let's start reading this out. So Apple released a new watch. They know from past experience they will sell 10,000 watches in the first week of release at £140. Okay, so £140, they will sell 10,000 watches. And they also expect to sell an extra 1,000, so that'd be 11,000 watches every time the price goes down by £10. So that'd be £130. And we could keep this going, so that there'll be 12,000 watches. And they will sell 13,000 watches if it goes down to £110, etc., etc., etc. So the first thing is write a linear model to represent the number of watches sold. So let's put just C for cost, and let's call that T. Now there's a few ways you can do this. If you think of a linear model, we think of linear graphs, don't we? If we think about so let's say this is cost and this is total. So we've got a few numbers here. Let's just do the top three. We've got 120, 130 and 140, and their respective numbers are so 12,000, 11,000 and 10,000, and it looks something like this. So if you to plot those, and you can see because it's going up by the same amount or down by the same amount, it is going to be linear. I'm just going to try to draw this line in. Okay, there you go. So it's definitely linear, and normally we have y equals mx plus c. You know, that's what we're used to, but this is now not a y, is it? It's a t. We've still got the gradient. Let's keep that as m. We haven't got a c. Oh, that's annoying, isn't it? So let's change that to p for price. So now we've got p and then plus c. Okay. So we have to find out the gradient and the Y-intercept, and that's our linear model. That's it. So how can we do this? So gradient, that's pretty easy, isn't it? We could do the change in y of change in x, or y2 minus y1 over x2 minus x1. So there's 1,000 there, and there's 10. So that has to be, so therefore the gradient is negative, guys, yeah? So 1,000 divided by 10 is 100. So far we have got t equals minus 100p. We can tell it's going to be a plus because the y-intercept's up here, and this is when p is 0. So you could put a c there and sub in a value like any of these, and you'll get the answer I'm about to give you. So that's a nice way, subbing in. Or you could think of it this way: when p is 0, if we continue this down to when the price is 0, you can see that's 11 more steps. Yep. So 11 more times of reducing the price to 0. So then we're going to add on an extra 11 thousands. So what's that going to be? It's going to be 24,000. So it's going to be 24,000. So that is our linear model. That will represent this information we're given up the top. Okay, so that's part A. So now part B, let's pop a B over here. It says, work out the amount Apple should charge if they want to maximize their revenue. So the questions are normally a little bit nicer than this. I'm just painting the worst case scenario. But revenue, that is equal to your price times the amount you sell. Do you need to know that? Probably not, but it's pretty obvious here. It's not profit, it's the amount you're going to generate in, is the price per item times the amount that you sell. Now, the total amount you sell, well, we've got that here. So that's 24000 minus 100p. And the price, well, that's just a p, right? So R is equal to this. Now, to maximize, we're thinking of turning points. So let's just expand this. So R is 24,000p minus 100p squared. So if you think what that's going to look like, it's unhappy, quadratic, and it's got a 0 y-intercept. It's going to look something like this, where this is R and this is P. And the maximum is going to happen here, and it's this value of P. I'm going to call it P1. That's what the question wants. What is the price that Apple should charge to maximize their revenue? So if they charge anything down here, they're not maximizing. If they charge too much, they're not maximizing, based on this model. So let's complete the square and find out what value that has to be. So it's a negative, so I'm going to factorize. Change the sign of everything in there. It is not 1p squared, so I'm now going to factorize again for the 100. And I will get that. Now we're ready to complete the square. I'm just going to move it up a tad. So 100, lots of p, minus 120 all squared. Always take away this squared. I don't often put the minus there because it's going to be a positive anyway, but remember it's 100 of those. And it's just a matter of tidying up now. So 120 times 120, well, that's got to be 144. I think it's that. There we go. Pretty sure it's there. You want to check. I haven't got a calculator with me today. And then we've got to rewrite this, by timesing throughout by -1. So it's 144,0000 minus 100 p minus 120 all squared. Okay. So this is R. This is their quadratic model for revenue. Now, what value of P will maximize this? Well, 120. So when they charge 120, this is 0. This is your maximum revenue. It's pretty tidy. 1, 2, 3, 4, 5, 6. 1.44 million in the first week based on this information. Okay, so hopefully that makes sense. They're normally far nicer to you on the question. They'll give you this formula and you just have to expand it and complete the square. But I thought if I take you right back to what it all means, it should make more sense to you. Okay, let me know if you like that or not.